information from the, okay, so we're recording. So we go back to the PowerPoint, and water is incredibly important. There's no life on Earth without the liquid and the frozen and the gaseous water. Water dissolves many things. It has a high heat capacity, which is being challenged unbelievably in global warming. If you think there's no global warming, then you're wrong. We have to have major changes for humankind and every other kind to survive. Water dissociates, means that it breaks up salt. If salt is dissolved, the water molecules help pull the sodium from a crystal, and they do that by forming these weak bonds. This positive side of the water molecule is attracted to the negative chlorine. The positive side of the water molecule, or the negative side of the water molecule, is attracted to the chloride, and so on. So positive is attracted to chloride, negative is attracted to sodium. These are not full charges. Water does not have 1 plus charge or 2 minus. But the fact that water can dissolve material, there's no life without water. Read that, know what proteins are, nucleic acids, and so on. Most of us are made of water. Know what acids are, like hydrochloric acid. Acids release hydrogen ion, bases release hydroxide, OH. pH measures the pH of blood, for instance. The pH of blood is around 7.35 to 7.45. If you have drastic changes in your pH and your body doesn't maintain that pH through the kidney and digestive system and the respiratory system, you will not live. The pH scale goes from 0 to 14. Acids are of low pH. Bases have a very high pH. Neutrality is 7. The more hydrogen ions, the more acid a substance is. The more basic, the more hydroxide, OH. The major buffer in the body is bicarbonate, HCO3. And the buffer of bicarbonate and some proteins and some phosphate help keep the pH of the body in this range. A salt is a compound like sodium chloride. These are electrolytes. They carry electrical currents. Everybody knows if it rains like today, you shouldn't go standing in pools of water if there's lightning around, unless you have non-conducting footwear. Organic compounds contain carbon, hydrogen, and oxygen. So carbohydrates, lipids, proteins, nucleic acids. Carbohydrates are simple sugars, double sugars, and starches. Store energy. You should recognize this as glucose. You will not be asked to draw this, but you will be asked to recognize it in its various forms that are displayed by different chemical notation. Glucose has 6 carbons, 12 hydrogens and 6 oxygens. It's a very important carbohydrate. You should know that a dehydration synthesis removes water from these two monosaccharides to make a disaccharide. So dehydration synthesis means water is removed from these two monosaccharides to form a disaccharide. The opposite reaction, where a disaccharide is broken into individual monosaccharides, is called hydrolysis. There, the water molecule is added back to replace the water molecules that was lost during dehydration synthesis. Glycogen is a polymer of glucose. Polymer means many parts. So your liver stores glucose by making glycogen. Read through this, know about these types of carbohydrates, examples, and functions. Lipids are water insoluble, so you should know the basic structure of fatty acids, fats, steroids, and phospholipids. So read through this chart, know about fatty acids, examples, function, and remarks. You should know that a fatty acid has a long central chain of carbon with hydrogen attached. This is the polar part of the molecule because oxygen is electronegative, slightly negative, whereas carbon and hydrogen form a nonpolar, non-charged, long tail attached to the oxygen, so this is the polar head of this molecule, and this is a long non-polar pole. A triglyceride has 3 fatty acids chemically bound to glycerol with a covalent bond. So you use dehydration synthesis to build a fat or a triglyceride, or hydrolysis to break a fat into its 3 components. So these are triglycerides, or fats. Fats are made of glycerol plus fatty acids. Recognizing your job is just recognize the structure of cholesterol with a 4-ring structure, and it's mostly composed of these carbon, hydrogen, and oxygen. And cholesterol is a very important part of your cell membranes, giving flexibility to your membranes. Phospholipids are very important. Phospholipids make up all cell walls. So you should know that this is the nonpolar tails, this is the polar head. So you should know that the presence of oxygen and phosphorus at this part of the molecule makes this the polar head. All carbon and hydrogen makes this the non-polar tail. So that means that phospholipids are arranged with the polar head either projected out to the outside of the cell or projected into the cytoplasm, because these non-polar tails cannot dissolve in water, and they are repelled by the polar environment outside of the cell and inside of the cell. So the cell is primarily surrounded by water, and cytoplasm is mostly water. Okay, let's stop there. Make another recording.